I'm going to walk you through the steps on how to factor out a GCF. But before I can do that, we need to take a trip back to elementary school and remember what exactly a GCF is. So when you learned it in elementary school, GCF stood for greatest common factor. And so if I gave you three numbers like 21, 35, and 14, and I asked you to find the greatest common factor between those three numbers, you would think about all the factors of 21, which are 3 and 7, the factors of 35, which are 7 and 5, and the factors of 14, which are 2 and 7, and you would notice that all of them have a common factor of 7. So you would say that the greatest common factor between 21, 35, and 14 was 7. Well, now we're going to be factoring out a greatest common factor in polynomials, and so not only will our terms have a number, a coefficient, but they will also include some sort of variable most of the time. So if I change this to 21x to the 5th, 35x to the 6th, and 14x squared, now, not only do all of my three terms have a greatest common factor of 7, but now each one of them also has a factor of x. And not just x, but they all have at least x squared. So I would say that my greatest common factor is 7x squared. 7 comes from the numbers 21, 35, and 14, and then the x squared comes from they all have an x, and the smallest amount of x's that any of them had was an x squared. So that's how we got that exponent. All right, now what if I added some more on? What if I added a y to the 3rd here, a y to the 4th there, and a y right here? So now, not only do they all have a 7 in common, they all have an x squared in common, but they all also have a y in common. And I can just say y because this one only has y to the exponent of 1. So I can only include y to the first power as my greatest common factor. Let's look at 3 more examples on how to first find a GCF before we start factoring out a GCF. In our first example, we're going to look at our coefficients first, 18, 24, and 12. So those 3 numbers have a few common factors. They are all divisible by 2. They are all divisible by 3. They are all divisible by 6. Some of them are divisible by 4, 24 and 12. Some of them are even divisible by 12, like 24 and 12. But our greatest common factor in this case is 6. So we know our coefficient of our greatest common factor is going to be 6. Now they all have an m involved, so we know our greatest common factor is going to include an m, and they all have at least m squared. We can't say any more than m squared. We can't say m to the 5th or m to the 4th because this one only has m squared. So it wouldn't be common if I said m to the 5th because this one only has 2 to give. So our final answer would be 6m to the 2nd. In our second example, 30, 15, and 25, again, there might be multiple common factors involved, but in this case, our greatest common factor between those 3 terms is 5. They all have an x, and the smallest exponent, we have 3, 2, and 1, so we can't take out more than one x. And if we're looking at the y's, we have 1 y, 4, and 6. So we only have 1 to spare there as well. So our greatest common factor would be 5xy. In the third example, there are no coefficients, so that means our greatest common factor will not include a coefficient. Looking at the a's, we have 5, 4, and 2, so they all have at least a squared. The b's, 3, 4, and 5, they all have at least 3. And the c's all have at least c squared. So our greatest common factor would be a squared, b to the 3rd, c squared. Now that we feel confident finding a greatest common factor, we need to practice factoring out that greatest common factor. So step 1 again, now I'm adding, instead of writing them with commas, I'm writing them as a polynomial. So you can see that this polynomial is a trinomial. It has 3 terms. So we're going to look at each one of those 3 terms individually, and we're going to come up with our greatest common factor between those 3 terms. So notice I'm using the same coefficients that I used in the very first example when we started the video. So our greatest common factor between 21, 35, and 14 is 7. All right, notice that a couple of the terms also have an x, but since 14 does not include an x, then x is not going to be part of our greatest common factor. So in this case, when I'm factoring out a greatest common factor, I can only factor out the coefficient 7. All right, now when we're factoring out a greatest common factor, basically what we're going to be doing is the distributive property backwards. So now I'm going to pull a 7 out of each one of those terms. When I say pull it out or factor it out, what I'm basically saying is we're going to divide each one of those terms by 7. So if I divide 21x cubed by 7, I get 3x cubed. Or when I divide 35x squared by 7, I get 5x squared. And when I divide 14 by 7, I get minus 2. So now you can see I've got a set of parentheses. I've got my 7 factored out over here. If you were to distribute the 7, you will end with what we started with originally. So we really are just doing the distributive property backwards here. And you can always check your work by using the distributive property at the very end. All right, so here's our next example. First step again is to find our greatest common factor. So this time we only have 2 terms. It's a binomial. Our greatest common factor between 16 and 32, again, they have lots of factors in common. We've got 2, 4, 8, but 16 goes into 16 and it goes into 32. So our greatest common factor that we can pull out of our 2 coefficients is 16. This time they do both have a w. So we can at least pull out w. This one only has w to the first power, which means it only has 1 w to spare. All right, so we're going to factor out a 16w from both of these terms. And when we factor it out, basically we're dividing both of those terms by 16w. So when I take 16w squared divided by 16w, 16 divided by 16 is 1, and w squared divided by w, we just have 1 left, 1 w left, w to the first power. Then plus 13 divided by 16 is 2. We only had 1 w to spare and we pulled it out, so there are no w's left. So our answer would be 16w times w plus 2. And again, if you were to distribute that back out, let's go ahead and do that actually. 16w times w is 16w squared, and 16w times 2 is 32w. So we end with what we started with. Let's try a couple more examples. In the next one, we have another trinomial. Our coefficients are 24, 16, and 32. So when I'm thinking about common factors, I look at the smallest of the 3 numbers first. So 16, we've got 2, 4, 8, 16. So the biggest one of those numbers that also goes into 24 and 32 is 8. So that means our greatest common factor is 8. But then we also have some m's and n's in common. So let's see, m's, they all have at least m squared. And they all have at least n to the first power. So our greatest common factor is 8m squared n. And so we're going to divide each one of these terms by 8m squared n. So 24 divided by 8 is 3. We started with m to the 4th and pulled out 2. So now we have m squared. We started with n squared and pulled out 1, so we just have 1 left. 16 divided by 8 is 2. We started with 3, took out 2, we have 1m. Started with 5, took out 1n, into the 4th. 32 divided by 8 is 4. Just making sure I'm not coming off the screen here too much. M squared, we pulled out m squared, so there are no m's left to spare. We started with an n and pulled out an n, so this is not going to have any n's either. So we're just going to leave it just like this. And again, if we were to distribute that greatest common factor, we'll end up with what we started with. All right, let's try one more example. In this last example, notice our coefficients 3, 7, and negative 6. They don't have any common factors. So we're not going to have a number to pull out as part of our greatest common factor this time. But each one of these terms has a y. And they all have at least y squared. So in this case, our greatest common factor doesn't have a coefficient. Our greatest common factor is just y squared. So when we factor out that y squared, we're going to divide each one of these terms by y squared. And when we do that, we get 3y to the 3rd. Basically just subtracting the exponents here. we have 7y to the first, and minus 6, we started with y squared, we pulled out a y squared, so we don't have any y's to give up there.